So, as we're looking at the correlation, the least squares regression line, remember that that is really the same thing that we're talking about when we're talking about the line of best fit. Okay, so be able to recognize those terms kind of synonymously. So, you know, same thing. It's the same thing as the line of best fit. What I want to talk about today is you know, we were finding that line so that it would model our data. Okay.
Mr. Nixon, I'm sorry. I have a quick question. Tomorrow, are we just so there's no new topics?
No.
Okay.
All right. So the whole point of creating that model is, of course, so we can use it for something. All right. So when we got this line of best fit, the point of doing that was so that we could do something that's called interpolation. Okay, interpolation. When we're doing linear regression, the point furthest to the left is called the lower pole. All right. The point furthest to the right is called the upper pole, and that's where we get the polation part of these terms. Okay. And if you think about the terms here, and you understand the prefix, it makes sense. Inter means between or within. All right, so interpolation is when we're going to try to predict values of that of that dependent variable by plugging in different values of the independent variable. Okay, so we have all this data and we say, okay, well, what would y equal when x was this? So we could come over, plug that into our model, and figure out what that value would be. Okay?
So we're looking for the dependent variable by plugging in the independent variables to the formula?
Yes.
Okay.
Yes.
Sorry.
Okay? And typically dependent, you know, a lot of times we'll use y. Independent, remember, is our x. Okay? Extrapolation, extra kind of means beyond, all right, or outside of. Extrapolation is when we're predicting using x values that are beyond the pole on either side. Okay? So for example, if we were to plug in a value of x over here and try to use our model to find what y would be, okay, that would be considered extrapolation. All right? Now we'll talk about kind of the validity of this, of doing either of these in a moment. But does this make sense in concept at least so far? Okay. So, how do we interpolate or extrapolate? All right. Well, first of all, there's a difference between kind of what you could view as reliable and what is appropriate to do statistically. Okay. It's possible to get numbers that are at least somewhat reliable, but it's really not appropriate if you're doing some kind of a statistical analysis. And they actually ask some questions about this when you're doing on the IB exams. They'll ask, you know, comment on the appropriateness of finding this value. And you have to understand, you know, how to determine that, okay? But just running through the kind of the process here, of course, you're going to find the least squares regression line, and you're going to simply plug in values for x, all right? You do need to identify assumptions that you're going to make. You know, for example, x is never going to be less than 0, or there's a certain limit to what y can be, or, you know, what are some other assumptions you're making about your data itself? You're assuming that your data is not, you know, abnormal or skewed, or not skewed, but is not like outlier, affected heavily by outliers or anything like that. Okay? So you need to identify those assumptions that you're making. Another thing is always to interpret your slope and your y-intercept. We did a little bit of this yesterday with the illustration of the traffic cameras. Okay? All right, so talk about interpolation, extrapolation. Always interpret your slope and y-intercept. That's important to make sure you understand what the situation is. Okay? You really get what this is modeling. All right, in our example with the traffic cameras, you know, your slope was a negative 1.06, I think. And we said, you know, that means that the traffic cameras have an influence, and there tends to be a decrease of about 1 traffic accident for every camera that we install. And we saw the y-intercept, it was somewhere like 52 or something like that. So we said, you know, if there were no accidents at all, or I'm sorry, if there were no cameras at all, we would have approximately 52 accidents. All right? So all of this that we've done already. We need to identify limitations, though. Anytime we're using a model, and for one thing, the strength of your correlation, which means we're looking at what value? The R value, okay? The strength of your correlation is going to determine whether your line of best fit is reliable or maybe how reliable it is, okay? If you have a really low R value, then your model is probably not going to really give you that accurate of results, okay? Interpolation always tends to be more accurate, and honestly, interpolation is always, it's the only type that is appropriate, okay? It's the only type that is statistically appropriate, okay? Now, does it mean that doing other things can't be useful in some circumstances? Yeah, but we're not going to really base anything really that important on that, okay? Because statistically, we can't be real confident in those numbers, all right? So this is the only type that's statistically appropriate.
Wait, I have a question.
Mm-hmm.
I don't have day 11. Unknown ability.
All right, so extrapolation, going beyond the poles, can be kind of accurate if you're really close to those poles, but like I said, it's still not statistically appropriate to do that, okay? So if I were asking you, you know, here's our data, is it appropriate to find this value? Even if it's just barely past the pole, we would say no, it's not statistically appropriate, okay? And it certainly wouldn't even be appropriate or reliable if it were far beyond the pole, okay? And then finally, this is another thing. It's not appropriate at all to try to predict the value of the independent variable by plugging a value for the dependent variable, okay? So we're not going to be using values of y and then solving for what x is. And that has to do with the fact that the test we're doing here, the correlation, the very fact that it is a dependent variable, we're saying that it's being influenced by that independent variable. That influence doesn't necessarily go both ways, okay? Now, you may have a situation where there is kind of an interdependence, and you just, in those cases, you're allowed to just pick one to be x and one to be y, all right? So there might be some reliability in doing this, okay? But we would never do this. We would never do this and really call that, you know, statistically significant or appropriate. It would just be the kind of thing where you're doing it on your own and you can get a kind of a decent idea of what it might be, but definitely with some reservations there as to how reliable that number might be. Okay? So, those are some things you got to consider, all right? Interpolation is the only type that's really appropriate. The other kinds, while they might be useful in some very informal contexts, we would never use those. We would never use those in a setting where we want formal results or something like that. Okay? All right. So that's everything new I wanted to talk about. Now it's just a matter of practicing to apply some of these things. Okay? So we're going to take the time we have here and start working on some of these. Notice this first one. We've got the amount of time a collection of families spends preparing homemade meals each week, and then the amount of money they spend each week on fast food. Okay, so just thinking about the situation without running any numbers yet, what would you kind of suppose would be our results here?
The more time spent on homemade meals, the less money on fast food.
Okay, good. The more you're spending making your own food at home, the less money you're going to spend, on fast food. All right? So that's what we would kind of assume just using our common sense or whatever. But the question is, does the data back up that assumption? Okay? So that's what we could study here. So we collect a number of data points from a number of families over the course of a week. So I'm going to have you guys go ahead, do your scatter diagram on your calculator, calculate R, okay? Find the equation of the least squares regression. Remember, if you save it as L1 when you're doing your correlation, it'll be there for you, okay? But then part D and E are really the parts I want you to make sure that you take some time to think about, okay?